Nuclear fission. It is a process in which a heavy nucleus splits into two smaller fragments, and in the process a large amount of energy is released, and that process is known as nuclear fission. It is observed that when a neutron bombards with a heavy nucleus such as uranium, then it splits into two nearly equal fragments, and in the process energy is also released, and that process is known as nuclear fission. Generally, uranium nucleus, let us consider the equation U-235. When it is bombarded with a neutron, results in a complex uranium nucleus, and this is unstable and splits into two other nuclei. One is barium, another is krypton, and in that process three more neutrons are emitted, and with the emission of large amount of energy, that Q stands for the energy released in the process. See here, this equation tells that you have a uranium nucleus which is a heavy nucleus, and it is bombarded with a neutron. Then the neutron is totally absorbed by the uranium nucleus, and a compound nucleus is obtained with a mass of 236. Since this is highly unstable, it immediately splits into two nearly equal fragments. One is barium nucleus, another is krypton nucleus. Then in that process three more neutrons are emitted, and also a large amount of energy is also released in the process, and this process is known as nuclear fission. From where that amount of energy is coming into picture is, if you determine the mass of interacting nuclei, that is before the fission process, whatever the nuclei that are there, if you consider that mass, it is large when compared to the products that are obtained after the fission process. The products are barium, krypton and three more neutrons. If you calculate the total mass of this one and this one, it is observed that the before the process, fission process, the mass is more than the mass of the product nuclei. The difference in the mass is converted into energy according to Einstein's equation, E equal to mc square, and that is what we got here, energy Q, the Q value. Generally, if you take the masses of interacting particles before the fission process, it comes out to be 236.0526 AMU. That's the total mass of the uranium 235 and neutron before the fission process. And after the fission process, whatever the products which you got, and if you consider the total mass of all the three, then what you will get is 235.8306 AMU. Obviously you can see this mass is large and this is relatively less. If you take the difference between these two masses, you will get 0.222 AMU. That's the difference in the masses. For each 1 AMU,